Hello everyone, welcome and thank you for attending today's IBM Middleware User Community Ask the Expert session. I'm Kelsey Tipshirney and I'll be moderating our session today. Our topic is feature and functional overview of IBM Netcool Agile Service Manager version 1.1.1. All phone lines are currently in listen-only mode. We will have a question and answer session towards the end. However, if you have a question at any time during our presentation, feel free to use the questions box that's located in the GoToWebinar dashboard panel for you there. And then tomorrow we will have the recording and slides of today's presentation available on the IBM Middleware User Community website for you to access. You will receive a follow-up email with a link to download the replay from today, so stay tuned for that tomorrow. Okay, so now I'll go ahead and introduce our speakers for today. We have joining us Krishna Kodali, he's an IBM Senior Software Engineer, and we also have Scott McQuillan, he's an IBM Principal Software Engineer. Thank you both for joining us today. I'll now turn the floor over to Krishna.
Thank you, Kelsey. Good morning, good afternoon, good evening, everyone. So today's topic is on the Netcool Agile Service Manager 1.1.1. I'll be joined by, like Kelsey said, Scott McQuillan. He's one of the senior developer and a key pillar of this component. Some legal note, because we will be talking about upcoming release that is not GA yet, hence this note. The agenda is brief. We won't be able to cover each and every piece of the ASM, so we have limited this to certain sections of the ASM that covers the introduction, the architecture, and how to install and upgrade, because we have now 2 releases right from its birth, and the available observers, and we'll walk through those, and the merge service followed by demo, and we'll take the Q&A at the end. This slide, maybe you can say this is mainly for CTOs or maybe solution designers, not typically meant for tool admins. But the message here I want to deliver is IBM Operations Management that enables you, the operations team, like the slide says, to increase the effectiveness, efficiency, and the reliability by providing a consolidated view and actionable insight into the health and performance of applications and the associated IT and the network infrastructures. The focus for this session is limited to how can you manage the dynamic IT infrastructure, critical services management of the network functional virtualization, and SDN using ASM component. If you have 5 pillars here: operations management and so forth, network performance management, cross-domain topology, and so forth. If I move on to the next slide, I have taken all that 5 pillars here just to categorize them into components/products into the reality when you deploy the products. If you take NOI 141 or 1411, so we have the event management that comes with the Omnibus probes with the Netcool library and the event storage. And then we have the network and performance management that comes with the various components here: ITNM, NCM, NPI, that's the new addition as well, topology search, and network health dashboard, followed by device dashboard. The focus today is on the dynamic topology that is mainly central on the NFV/SDN that comes with the 2 components: Agile Service Manager and Agile Lifecycle Manager. And we do have the Operation Analytics. That's 3 other components there. And then we have the hybrid offerings, which goes on more on the SaaS-based runbook automation, alert notification. The new piece is Cloud Event Manager. And all these pieces are glued together using the NOI fabric. So irrespective which pillar of them you take, you will always have that fabric: installation manager, WAS, dash, so forth. The only optional component there is TCR. If you want to know more about the ASM introduction and the in-depth demo of the OpenStack one of the observer, you can watch the previous session that was presented by Matt Duggan. With that, I'll pass on to Scott to talk about the ASM architecture. Scott, floor is yours.
Okay, so basically I'm going to first of all run through a bit about the architecture of ASM. And so I'm going to go through the benefits really. I mean, one of the main goals is to get a real-time topology just to keep up to date with these changes, because these new environments, VMs are spinning up and down, containers are coming up and down, you know, people are scaling out their systems, scaling them in, and the traditional kind of nightly batch-based discovery, it just can't keep up. You just don't see all the dynamic changes within your network. So one of the benefits we want to offer is to see stuff as it happens. But also important is to keep a history of those changes, so you can rewind and go back in time, as it were, and see what it was like, you know, a few hours ago or a couple of days ago. Because the changes in the topology could well lead to problems in your network, and some of the events that you have in Omnibus might have been as a result of a change, or they may in turn have caused a change. So having that history is important. We've got some Google-like search capabilities and some which we'll see in the demo, so I won't talk too much about that. The cross-silo integrations, that will kind of get covered a bit in the merge process later in the presentation. And I'll also talk more about the REST APIs and embedded documentation as we go through. So if we move on to the next one, I think. This is really in just as a kind of screenshot to give a foretaste before we go through the demo. In essence, what is showing here actually is part of the dynamic topology change and, well, history as well, in essence. So that storage one device is, you can see it's grayed out because it's actually, yeah, at the time that we're looking, that storage device has been deleted. But again, I think we'll get into the architecture and we'll come back to the UI in the demo towards the end. So if we go to the next slide. So again, I won't read through all of this. You can read them in the deck. But I mean, these are just some of the aims, really. Some of which we covered already. But it's, you know, to keep up with the real-time stuff, to have topology history, to consume data from multiple different sources simultaneously, and that needn't necessarily be network topology. You might, you know, anything, many things can go on a graph. You might have your company org chart, and you might actually put people in the graph and assign them to resources and things. So there's not really any restriction on what gets modeled. So if we go on to the next slide. This is just trying to illustrate that we're fully leveraging all these new kind of cloud type applications. So everything's running in Docker. We have the Cassandra database into which we store the topology, which can be clustered and run in the cloud. They've got Elasticsearch is supporting the search engine. We have what used to be Titan Graph and is in essence morphed into Janus Graph, supporting the graph database that we're storing the data in. We're using Kafka to shunt our messages between the different microservices in ASM, and we're using Swagger to provide the online API, REST API documentation framework, and we'll see some of that in a bit. Drop wizards in there for good measure. You probably won't see it really. It's just in essence the framework in which is running all of our web containers and things. So if we go on to the next slide. Okay, so this is the general architecture of ASM. So right at the top we've got the stuff you should be more familiar with, which is Dash. Into Dash we install the ASM UI, which we'll see later on. And then there's Omnibus. In order to integrate with Omnibus, we require the XML gateway to be configured to send us events. We've got a number of observers. We're going to cover a few of them later, but there's just kind of one example at the bottom there. And then we've got three principal microservices, which are the topology service itself, the merge service, which we'll talk about later, and the search service, which we won't really cover here, but we'll see it in action a bit in the demo. If we go to the next slide, Krishna, which is the variation of this one. So here was just a walkthrough of how a typical observation of, in this case, the ITM observer might work, just to kind of give people an idea of the data flow. So, number one is going to start off with somebody requesting a job be run. We'll see a bit more about how you would request that. But in essence, you're asking the ITM observer to go and fetch data from ITM. The first thing it will do actually is ask the topology what it saw last time, because it needs to keep track of that in order to know what it didn't see, because it's going to need to delete what it didn't see, because ITM gives you the current snapshot of the network. So the ITM observer itself does a difference with what it saw before and what it saw now, and will delete those devices which no longer exist. So the observer will then post all the topology onto the Kafka message bus, and number 5, you can see the topology service reading that data out, processing it, inserting it into the Cassandra database. As each record is processed and inserted, number 4 indicates that we have on the Kafka message bus, we broadcast out all the updates of what changes took place, if indeed any changes did take place. Those changes are consumed by a couple of listeners on that Kafka bus. One's the search service in order to facilitate the search in the UI, and the second is the merge service, which may decide to merge resources from different observers. And again, we can cover that in more detail later, so can't do any more. And finally, we've got the number 7 is the UI, which is the only way the UI communicates with the likes of the search service and the topology service is via REST. There's no other protocols involved there. And finally, the event observer, you can see consuming events from the XML gateway. The event server will query the topology service via REST to do the lookups, and then it will, if those events are successfully looked up, it will put them on Kafka message bus so that the topology can consume those as well. And if we go to the next one, this is just a deep dive of one of the microservices, in this case the topology service. So because it's running inside a Docker container, it does have a config file, which you can edit, but typically that's not the way you do things with Docker. So in essence, the configuration, and there really isn't a lot of configuration, to be honest. You wouldn't expect to edit these files, but what configuration there is controlled by environment variables, which are just set at the time that the containers start. But there's no config or anything stored within the topology service container. You can rip the container down and bring it up again. All the state is stored within the Cassandra database. And we do have an external mount of the logs, so you can access the logs from outside of the container. So if we go on to the next slide. This is really just a screenshot to try and illustrate that the Swagger documentations and the REST APIs are really key to how ASM works. That's an example of the Swagger from Topology. I'll show you a little bit about that in demo later, so we won't go into a lot more detail here. I think the next slide is just showing, again, this is another microservice. This is an observer service. They all follow basically the same pattern, and they all share a bunch of common code that makes them all behave in roughly the same way. So again, they're inside a Docker container. Their initial setup is controlled through environment variables, which you wouldn't expect to change. The install will do that. It's mainly just things like the host name and ports and things that they should be using. And so they communicate either via REST, which is where you would tell them to start a job or stop a job, or see what jobs are running. And once they've completed an observation of something, they will post the results of that observation onto the message bus. From there, it will make its way to the topology service. And we will cover a few of the observers in a bit more detail later on, but I think it's back to Krishna now after this slide for the installation piece. Oh no, sorry, I did have a screenshot from the observer Swagger as well. So again, you can see what we tried to do in a Swagger is give you enough online documentation to figure out how to use it, etc. And I can show you some of that in the demo live as well.
Thank you, Scott. I'll cover the installation piece. Given the time constraint, I would like to zip some of these slides. I have put enough backup slides as well, just for reference. When it comes to ASM installation, I think this is probably one of the shortest installation process within the NOI suite. Probably takes about less than 20 minutes, both ASM core and UI to install, as long as you have the underlying prereqs met. So here I have given a NOI 1411, but ASM was introduced in NOI 141 as a version 110, and the latest release of ASM is 111. So if you look at it overall, ASM is part of the dynamic topology, the pillar we talked about, and here we have two components: ASM core itself, and then ASM observers. When you download the ASM, one of the component there, the top one, CJ1, it will bring both ASM core as well as GUI piece. I've given two arrows there, one download from the Passport Advantage, other from Fix Central. When you don't have anything from Fix Central, what it means is if you are a fresh user, if you haven't deployed 110, you can install straight away 111. You don't need to go from 110 and then to 111. That's what it's meant. And I have given the compatibility charts. It's in one of the developer works for both 1411 and 141. I have not listed each and every component of NOI here. That table, the top table, is just a subset of what is within NOI. There are a lot more components. The slide we talked earlier, it talks about each and every component. So the installation process, the ASM has two pieces: ASM core, ASM GUI. The ASM core goes strictly on Red Hat, similar to Network Performance Insight, NPI. The installation process is done via M2 with the Red Hat native, and you need to have the ASM requires the Docker, that specific version or higher, and you need to enable the extras package for if you are going with the 110. If you are with the 111, you also need optional package that installs the PyML as well. The installation from 110 or 111, either you are doing an fresh install upgrade, it's pretty much same process when it comes to ASM core. These are just the packages when you download, and what are all the components that comes with it, and the description of those. And the RPM package tied to them, and you just unzip them and install them using the M package. The next one is, I'll slide these slides, and you must accept the license so that your ASM is functional, otherwise you'll get the warning. The layout is pretty neat with an ASM, so you have the ASM home. Within that you have the Docker ASM scripts and Docker Compose, and then the data location followed by the configuration, where all the container images are there, and the license, and then logs. The Docker Compose itself, you can see what are all the scripts, the admin scripts you have, and that also includes each and every observer as well. This slide talks about the logs folder and the subdirectories. Within the log, you have associated each and every service, including the observers here, if you are trying to troubleshoot any problems. It's all in one central location, and you navigate from there to the respective service. The Docker Compose has all the services defined and the network tied to it for all the containers to work, and the granular configuration is pulled from the specific YML file. How you kick off the ASM containers using the Docker Compose is listed here. The only caveat is you need to have the ASM home set, the variable, along with the path, which is ASM home/bin. I have listed those details. As long as you have set them, you should be able to run the Docker Compose commands or Docker commands. The uninstall process is pretty simpler. It is same drill. If you uninstall Netcool ASM-common package, that will uninstall all the associated packages as well. But if you want to remove a specific observer, then you can do the same drill, but you just define appropriate observer name using the M package. If you are going from 110 to 111, again, it's kind of a twofold process, only if you have the observers deployed on more than one server. But typically, if you have all the observers along with the ASM core, then it's not a twofold process. So the ones I highlighted are the packages from 111. In the bottom one, I have highlighted the ASM UI, just one zip file. Again, even though you're doing upgrade, the process is via a same command, the minstall process, all the RPMs. Once you are done with the ASM core, which means your Kafka, Zookeeper, and Cassandra, and so forth, if you have observers on the same host, I would advise you untar the second, all the observers as well when you are upgrading this. But if you haven't done it, you will come with this warning saying that you have orphan containers. What it means is they are disassociated with the latest ASM core package. You can tie them back if you like, but we advise you use the latest observers associated to version 111 because there are fixes, changes, and latest features in those observers. This is the second step. So you untar all the observers, unzip them, and install them wherever your ASM core is. The process is the same. It will update if you have existing observer. It will install if it is a new one. I have given a few commands for the Docker, but since it is a third party, you can get more information outside rather than we giving details. You can log into how you can log into a specific container using the Docker x-ti with a bash shell, or whatever shell you like, and how you restart the Docker and so forth. The UI installation, it's pretty much same drill. Like Scott was saying, this is the one single portlet that is the topology viewer that is part of the ASM. And it allows to visualize the data from the topology service. A few notes here. Unlike ASM core, you can deploy ASM UI in multiple. It supports multiple OS. You can see the details there. And the prereq is nothing but NI fabric except the TCR. You don't need to have anything else. But we advise that you stick to specific NI version so that you are on that particular level with other components and you are compatible so that you don't run into any known issues. So either you be at 141 NI or 1411 for the underlying components. The installation drill is same using installation manager. You download the package, add the repository, and then add into the IBM Netcool GUI components. This slide is talking about there is a test connection. In the GA code, you define the topology service, what is the host name and the port number, and the search service. But in 111, we added the test connection so that it tells you whether the connectivity is there or not, just for some confidence. So that it is communicating appropriately rather than you troubleshooting post-installation, if that makes sense. And post-installation, all you need to do is you assign the IN, IBM Netcool ASM operator role to the appropriate user account that you operate the dash, and then you should see that topology viewer. If you are upgrading, then again, same drill. You download the 111 package, unzip it, and upgrade it rather than install. And that will update the package. One caveat here, so even though we are saying GA code is 110, the UI component underlying version is 113. So if you are validating within the dash, don't get confused. That's how it is. And 111 comes with the version 115. But if you are validating the core version, ASM core, you look for an ASM common package, Netcool ASM common package. You can see there 110, that's the GA code, that's the version, release, and the modification. And the last piece is the build, which we don't care. And the later version 1.1.1 is, you can see appropriately there. The ASM topology view, I will not go through much detail here. So you have a navigation bar and the visualization toolbar. It's pretty much similar to what you see in the ITNM maybe, but it gives a lot more granular details when you look at the demo. And the navigation toolbar, I'm not going to read that. And then this is the strength of this product, having the topology history. You can navigate what has changed from the last week to this week and so forth. If you are trying to compare with ITNM, we don't retain the topology changes there, but ASM gives you that opportunity. And the post-installation, all you need to do is define the observer job. In this case, I just listed the ITNM. Once you define the job, you just kick off the job operation, and I have listed the link to the docs that defines each and every observer. I'll now pass on to Scott, talk through observers. Scott, go ahead.
Okay. Yeah, so I've just listed what observers we have on this one. So in the GA release, we had ITNM, OpenStack, a file observer, which effectively can just read a custom file that as long as you create the lines in the file to the correct syntax, you can load in any custom topology. We have a Docker observer which initially just monitored ASM itself, but it's becoming more generic, and you could monitor other applications running in discrete Docker engines. So I can probably show some of that in the demo. But in essence, that will show whether all the containers within ASM are up and running. And the event observer we already briefly talked about, which is consuming events from Omnis via the XML gateway. Now in version 1.1, we had another 6 observers. I'm going to talk primarily about the 2 VMware ones and also the ITNM one in the rest of this presentation. But we've got an observer for REST. Now you shouldn't confuse this with observing REST itself. It's basically in some ways similar to the file observer. You can insert your own topology data into the REST observer if you craft the JSON payloads in the same way. We have the TADM observer, does what you'd expect, pulls in data from TADM. We also have a Bluemix observer to show our cloud credentials. We're not going to talk much about ALM in this presentation either, but the Agile Lifecycle Manager can be used to spin up web services and scale them out, etc. So we also have an observer that is able to, in essence, look at what ALM has intended to spin up, and then it ties that together with what ASM has actually seen in via OpenStack or Docker observers as actually running, so in essence ALM provides the intent of what services it wants to run up, and ASM confirms that those containers have successfully been run up and merges the two into a single view. Now, new in 1.1.1 over 1.1.0 are the merge service, which we'll talk about more here. There are some UI enhancements, custom icons, etc. I'm not going to go into any detail there, but we'll see some of that in the demo. Now, we've chosen to demo. We've chosen to demo some of the code from the beta rather than 1.1. That's because it's got 2 new features which we think are really useful here, which is the layout service, which we'll see later, and this new element to host view. Again, the reasons why we're showing those will become apparent during the demo. So if we, I was going to say, so although that code isn't GA, it is a beta. If anybody wants to get their hands on it, they should contact us so we can get it onto the beta program. Now, again, I'm not going to read all this, but the observers basically work on the concept of a job. A job you can think of as an observation. It's in essence go and discover this, etc. Jobs have a unique name. Each observer might have a single job, or some of them have got 2 different flavors of job. ITNM has two, for example, which we'll see later. It has a batch job and then a listening job to keep up to date after the initial batch has been loaded in. So if we move on. Okay, so there's about 3 different ways you can start a job. Krishna covered one earlier, which was the scripts. Another way is you can actually just go into the online Swagger documentation and just fire one up straight away. So they're live. So in essence, you would click in that box on the right where it's got the example model. That would automatically populate the Swagger there. You may need to correct the name of the file from the example to match the file you wanted to load. And then you can just click go. If we've got time in the demo, I can show you roughly there. So next page is, again, this is the third way of starting a job. It's just basically we're posting the job to the REST API via curl. If you actually look in the scripts that we provide, they're doing this type of thing. So in essence, the parameters there in this example was telling ITNM, in this case, I think it's, yeah, so in essence, the James domain in ITNM is accessible via port 7968 on NCP config, and basically, if you post that job, ASM will connect to that host on that port and download data about the James domain and load it into ASM. So for the next. But yeah, so now we're going to briefly cover the 3 different observers that have provided data in this demo. Not really a lot to say on this page other than the ITNM observer does load topology into ASM. And one of the reasons we do that is in essence there's not, you know, ASM complements and ITNM complement each other. There's no plans to make observers in ASM that would observe Cisco switches and network kit. The piece in the portfolio that does that is ITNM. And that will continue to be the case, and ASM will get its data from ITNM, not, yeah, so it's not, in essence, not replacing ITNM, it's adding to what ITNM can already do. Move on to the next one. We probably talked about this already a bit briefly, but yeah, so the ITNM observer in essence has 2 jobs. It uses OQL to just communicate with NCP config, which is the way the ITNM UI actually communicates with the core. So its batch job is just to select from model, and its listening job is it will hook into that the message bus in ITNM and listen to any updates that go past and apply those to the topology. So let's go to the next one. Okay, so there's a bit of a theme here. We've got a VMware environment in our test network, and so I've included screenshots for the 3 observers we're going to talk about of that same environment, and all for the same seed. So in essence, what we're looking at there, and we'll see this in the demo in a bit more detail, but what we're looking at there is a Juniper switch Greenwick as the seed. And I said we wanted to demo the host element to host view. So this is not in the GA, this is in the beta. But this view is kind of a hybrid between the element to element view and the element to host view. The difference being that it's included the interfaces of that Greenwick switch, but it's only, there's about 200 interfaces on that switch. What it's chosen to do is include those interfaces which actually connect that switch to other devices. So you can in essence see which ports are being used to connect across the network. So if we move on, because we'll probably see a bit more of that in the demo. So if we go to the next one. So the next one is the VM vCenter observer. It's basically hooking into some vCenter REST APIs. It does a bulk load, and it can discover things like the hosts supporting the VMs themselves, what their storage is. Again, so if we move on to the next page, I'm conscious we're a little push for time. So again, architecture of this observer, like all the others, is pretty standard. It runs in a container. You post a job to it. It will go and query vSphere according to what you've told it is. it doesn't mention on here, but there is a little bit of configuration as a one-off you have to do for both this observer and the other one to get the certificates sorted out. But that's all covered in the documentation. It's not too painful, and you only have to do it once. So if we go on to the next slide now here, again, this is the same network, the same seed, but now we're looking at the vCenter, the vCenter's view of the world according to ESX7. And you'll see what vCenter can see is different to what we saw in the previous one. It can't see that Juniper switch. There's nowhere to be seen. But it can see several VMs. It's got a few CPUs modeled. It's found some operating systems. There's a Debian system running on that controller down there. It's found some storage. Now this is all stuff that IBM wouldn't see. So, you know, clearly this is adding stuff into the mix that we didn't know about before. If we go on to the next slide. So we've also got the observer NSX, which is the VMware component responsible for doing all the networking, and this can make distributed switches and etc. And it's used to help join both the VMs to each other and the VMs to the physical network that's supporting your data center. So if we go on to the next slide, again, not too much more to say here, quite standard once again. You know, post a job, it will connect to the VMware NSX server, it will pull what topology it can back and insert it to the graph. And on the next slide again is, once again, this is a third view of the world according to the NSX land of the ESX7 server. And you can see, you know, there's some commonality there. Some of those VMs were seen by the other observers, but again, it's all a bit, it's different. It's adding more information into the mix. And so the next section, basically, we're kind of saying, well, now we've seen three different views of the same world, but how do we pull those together? So this is where the merge service comes in. So the merge service is a separate microservice in the environment. It basically speaks direct to the Cassandra database, which stores the topology. So it's not using the topology service as an intermediary. It's hooking directly in. It is mainly read-only, but not completely. And so the data flow, we've already really covered that, but in essence, the job is posted, the topology service posts the updates, the merge service listens to the updates, and then we'll figure out whether or not it needs to merge any resources or not. So if we go on to the next one, this is probably a bit more low level than is needed, but this is the graph that we kind of build within the topology. What it's trying to represent here is those C1, C2, and C3 are three different resources. If you think in context of what we've just talked about, that might be three different versions of ESX7. So each is maintained separately, updated by its own observer. The observer doesn't even know that they're all the same, and we kind of, through a bit of smoke and mirrors, we actually just link the three within the graph and say, through this the purple square there, we're basically saying that these three resources are actually all one resource. But we're going to manage them with their separate life cycles, but we're going to display that, yeah, we know they're a single resource, so we'll display them as one. We'll see some of that in the demo later. So if we move on to the next one, I won't say too much about this, but there's as with most of our microservices, there's a REST API. This one, rectangular resource that or vertex that we saw before, we refer to that as a composite, and there's an API in Merge that will show you all the things that have been merged. Additionally, it does let you manually merge and split stuff if you need to. So if we move on. This was just a worked example that that we did to try and. I won't go into detail here, but if you look at the deck, you can go through it. But in essence, what we're doing is posting two resources in from the command line using curl. What's key here is that those two resources have a common merge token. It's just called UUID for host A. So once the merge service spots that, because the merges is all based on merge tokens, so once the merge service spots that those two different resources have the same merge token or any intersect in their merge token set, it will create that composite vertex that we saw in the previous slide. And then what the UI will choose to do, if it spots one of those composite vertices, it will actually show you a merged representation of those two individual resources. So what you can see there is right at the top, you can see it says composite of IDs, so that's saying that this resource is actually composite of those two. And you'll see we've got observer 1 and observer 2 are properties. So what you see in the UI is both those properties, but actually looking to the left, you'll see that one of those properties is in one resource and one is in the other. So if you move on to the next slide. Now, what we just saw there was a manual merge where the incoming data had set merge tokens. That's typically not the way we choose to do it, actually. The way we choose to do really is to create a merge rule that the observers can apply to the data and then get them to set merge tokens before they send the data to the topology. And so those are the properties of a merge rule. Most of them are fairly self-explanatory. You've got a unique name, you're enabled or disabled. Merge tokens is what properties you consider to be unique enough to use to merge two things. That might be a sys name or some UUID that you're getting from your observer. Entity types just lets you say I'll only use sysname on a chassis or a host. If there's a sysname property that happens to be on the interface, I'll ignore it. You can apply a merge rule just a specific subset of observers, and there's also a concept of a provider, which confuses some people a little bit. But in essence, the file observer can read multiple files, and in that case, we would say that the provider of that data to the file observer was the name of the file. So you can scope down to that level of granularity. And on the next page, okay, once again, I won't say too much here, but again, as we've said before, most of the services have Swagger and an API, so you can add a rule, select back a rule, update a rule, or via Swagger, and there's a few default rules included in the YAML file with an example of one there. We go on to it. So this is actually moving on from that previous slide. So we've already made the assumption that resources 1 and 2 have been merged. Now we've created a merge rule, which is basically what it's saying is I've made it quite a broad rule just for the sake of the example, but it's saying any host with my UUID property should get the value of that property promoted into a merge token. And then the post below on the left is basically posting a resource that matches that rule to the REST observer. So you'll notice that the REST observer, what we're posting doesn't have the merge token set, but the REST observer will actually apply the rule and set the token, which in turn would merge that third resource with the first two. And then if you looked at these in the UI, you'd now see that the composite of IDs has increased. We now have 3 IDs. I'm conscious we're a bit tight for time, but we're nearly through the slides, so if we move on. So the search service quite deliberately isn't aware of composite resources. So if you search for host A, which is what we saw in the example before, the search service will show you 3 of them, and there are 3 of them. And if you, so in essence, it shouldn't matter which one you actually click on because it's merged, so that they'll all take you to the same place in the topology. But there are 3, and they all have different properties, which is why it's showing up there. If we go, all right, so this is a little bit work in progress, so I've just put a screenshot in here. I'll show you in the demo that the element-to-element view does understand these composite resources and can show merged resources. But the element-to-host view, which is effectively new in this beta, and additionally the existing host-to-host view, they don't currently understand merged resources. I just wanted to include this here just to say that the plan is that the next, it will be in the beta hopefully soon, and it should be in the next GA release, which I think is planned for the first quarter. But what you can see here is it's got a bit cluttered, but we saw the 3 different versions of ESX7 topologies. Well, this is the merged representation of all 3 of those in one. And I think that was where the slides end. If we can try and let me share and run through a quick demo.
You should now have access.
Yeah, I'm trying to share Firefox. Right. Are you seeing a Dash login page?
Yep.
Yep. Okay, so this is a demo system with pretty much the entire noise suite installed, including ASM. You'll remember from Krishna's presentation earlier that we've got the topology viewer. This thing here with topology and events is a customized page, which I'll show you later. But in essence, here we've got the viewer. If I want to look at ESX7, which was that resource that we saw before, I'm in the, well, I'm just going to have a look at that. I'm in the element-to-element view. So there's ESX7 again. It has been merged. I happen to know that if I walk out from, so I'm using resource neighbors here to extend the topology, because I happen to know where the switch is. So I can do resource neighbors again. So now we're getting somewhere, and now we can do it one more time. So in essence, what I've done there is I've got ESX7 here. I've got devices over here connected in here that are not seen by ITNM, that are only discovered there. That was a composite, but it's those familiar with ITNM will realise that things like power state and stuff. This is from the NSX observer, that resource. But we've still managed to walk across the network over to this green book switch, which if you look at that, those familiar with ITNM will spot some of those. They might even know Will King, for example. So what we managed to do there is pull together the 2 worlds, as it were. So we've managed to show that the physical network that ITNM can see is joined up to this virtual network, which ITNM doesn't really have a lot of visibility of. If I were to jump to the element, in fact, let me resend. I can't really show you, as I say, these other 2 views don't yet understand composites. So if I recentered my view on this Greenwich switch, so if you recall earlier, I said there were an awful lot of ports on that. So what we're finding is the element-to-element view is a little bit cluttered, to be honest. I can increase the number of hops, and I just don't think I've got far enough out yet. So if I went 3 hops out from there, for example, so you can now see I'm starting to see some other devices here. And if I went to the host-to-host view, which is also in the current GA, yeah, I can see those devices. So So what we've done with the element to element view, or element to host view, sorry, is we've kind of done a hybrid. So now I can see that from the Greenwich switch to this router, I've actually got 3 different paths that I can take to get there. And also interestingly, I could see that 2 of them have got problems because I've got status on those. So actually I've lost quite a lot of redundancy there. And if I lost the last one, I would lose connectivity probably. So I said I'd show you that other view. So this is all GA code. Oh, sorry, the bottom post beta. But this is this view is, you won't get this out of the box with ASM, but you can configure an eventless portlet and the topology viewer portlet. You can configure them together in the same dash panel, and then there's some right-click tools which can get added to the events. So I could go down here and I could say, let me show this event in the ASM topology. I mean, none of this will be rocket science to people because you'll all have seen something similar with ITNM, but I just wanted to show that it's possible in ASM2. So I can hop from events across to the devices. And interestingly, the history, if I take this history down to like a minute and go and enter Delta mode, I might change the. Oh, so the other thing to demo here actually is the layout, which is in beta only, but didn't exist in till now. So I can change the layouts to get one that better suits my graph here. I think I'll probably choose maybe not the circular one. So I've got my layout here. I can see that I've got events on one of the links there, but you'll recall that there were actually events on 2. Well, actually, I've got my history slide. If I go back from that time there, I can see that actually I had no events at 11:29. I can wind closer up. Eventually, I can see the first few events start coming in. If I move a bit further on, I can see more. By the time I come up to sort of 11:30, I've lost both those links. So that's kind of a little demonstration of history here. That was in the context of events, but if another VM had appeared, for example, and been connected up to one of the ports on that switch, that too would have shown up in this view. And close to what I was going to show you, the other thing we've got that I was just going to show before we kind of open for questions is, oh, sorry. This is just the health view, which I mentioned earlier. So this is the Docker observer. So you can actually see that's the topology container. So yeah, it's got those ports open. That's how you're accessing it on Swagger, 8080, and it's got that image. That's the Docker image that's being run. Actually, I know I was going to briefly show the Swagger, just for those who haven't seen it. Yep, so I just wanted to... So again, if I went to the resource details here, I can see that I can copy the ID of that resource. I can go to my Swagger page. So this is a live page for the REST API into topology. This particular API call here, get resources ID. Well, I just copied that ID out of the UI panel. I happen to know the tenant ID is that's required as well. And I can query it. So in essence, that's just to kind of show you that the Swagger's there, is live. It's self-documenting. You can insert stuff and select stuff back. I also, well, for the sake of argument, had the file observer swagger open as well. So if I wanted to post a job, I could just click on that, and then I could change that to the whatever file I happen to want it to load, and then I could post it, and that would load that file into the topology for me. And that was where I wanted to stop. I think we've got 5 minutes for questions.
Okay, so if you have any questions, feel free to enter them in the questions box there on your dashboard panel so the presenters can get to those.
I haven't seen much, Kelsey. Let's give it 30 more seconds before we wind up.
Okay.
Okay, I'm not seeing any further questions, so we'll go ahead and close the session today. I did enter in a discussion forum link into the chat box there, so if something comes to you that you would like to ask our presenters, feel free to go to the discussion forum link there and submit your question. That's it for today. Again, we will have the recording and slides available tomorrow in our archives. You will receive a follow-up email with a link to download the slides and the replay from today, so stay tuned for that tomorrow. And this concludes today's session. Thanks, everyone, and have a great rest of your day.
Thank you.
Thanks, everyone.